In the spring of 1940, as the shadows of war lengthened across Europe, a seemingly impossible demand was laid before American industry. William Knudsen, the formidable president of General Motors, sat in his Detroit office on May 16, a telegram from Washington clutched in his hand. Its contents were nothing short of astounding. President Roosevelt had challenged Congress to achieve an annual production of 50,000 military aircraft. This wasn't merely an ambitious goal, it was a figure that defied all conventional understanding of manufacturing. The implications of this audacious target, and how America would ultimately achieve it, would echo through the annals of history, forever altering the course of the greatest conflict the world had ever known. Knudsen, a titan of industry with 37 years dedicated to mastering the intricacies of production lines and factory operations, understood the profound magnitude of Roosevelt's request. As the head of the planet's largest manufacturing enterprise, commanding over 200 facilities and 350,000 employees, and earning an unparalleled annual salary exceeding $300,000, he possessed an intimate knowledge of what it took to build. He wasn't just a manager, he was a brilliant engineer, and he grasped the true scale of the industrial mobilization the president envisioned. This was a call to arms for American manufacturing, on a scope never before contemplated. Consider the stark reality of the era. In 1939, the United States had produced fewer than 3,000 military aircraft in total. The Army Air Corps possessed a mere 1,700 planes, most of which were outdated. Now, Roosevelt was demanding a capacity for 50,000 planes annually, a number greater than all aircraft constructed in America since the pioneering flight of the Wright brothers at Kitty Hawk in 1903. The sheer audacity of the target was breathtaking. Knudsen understood that such a need signified that war was imminent, and with it, a complete upheaval of his world. Within 2 weeks, Roosevelt would personally summon him to Washington, asking him to leave General Motors and spearhead America's industrial war effort. Knudsen, without hesitation, would accept. By May 1940, the geopolitical landscape was grim. France had capitulated, Belgium had fallen, and the Netherlands was under Nazi control. Hitler's forces were pressing relentlessly towards Paris and the English Channel, leaving Britain isolated. Against this backdrop, Roosevelt was asking American industry to forge an air force of unprecedented size. The prevailing sentiment, however, was that such a feat was utterly impossible, especially in the eyes of America's adversaries. In Berlin, Adolf Hitler reacted to Roosevelt's speech with what his advisors characterized as amused contempt. The Führer's intelligence officers had meticulously compiled a report on American industrial capacity, and their conclusion was unequivocal: America simply could not produce 50,000 aircraft per year. They dismissed Roosevelt's claim as mere propaganda, an attempt to intimidate Germany and bolster flagging Allied morale. Their analysis, based on readily available data, seemed logical. American aircraft production in 1939 had indeed been less than 3,000 planes. German analysts, even accounting for maximum effort, projected that the U.S. might, at best, reach 10,000 aircraft annually by 1942. 50,000 planes remained firmly in the realm of fantasy. The German Air Ministry possessed detailed knowledge of American factories, including Boeing, Douglas, Lockheed, and Consolidated. They knew these companies built aircraft individually, relying on skilled craftsmen to hand-fit each component. There were no assembly lines for aircraft. While cars could be mass-produced, the Germans believed aircraft were too technically complex, with tolerances too precise and materials too specialized, to be manufactured in such a manner. A German intelligence report from June 1940 definitively concluded that Roosevelt's speech was a bluff, an attempt to deter German aggression. It asserted that American industry lacked the necessary machine tools, skilled labor, engineering capability, and raw materials to produce more than 15,000 aircraft annually, even under optimal conditions. The analysts were confident. America, they believed, was not a military power. It was a nation of farmers and carmakers, utterly unprepared for industrial warfare. The United States possessed no modern army, no strategic air force, and no experience with large-scale weapons production. German planners estimated it would take America at least 4 years to establish the infrastructure required for serious military output. By then, Germany would control Europe, rendering any American intervention irrelevant. Hermann Göring, commander of the Luftwaffe, further bolstered Hitler's conviction. He assured the Führer that while Americans excelled at building refrigerators and automobiles, complex military aircraft demanded German engineering precision. Americans, he claimed, lacked the industrial culture and technical sophistication for weapons manufacturing at scale. Hitler believed him, a conviction that would tragically prove to be one of the most devastating intelligence failures in military history. Yet, in America, one man quietly believed Roosevelt's ambitious target might actually be attainable. His name was Charles Sorensen, and he served as vice president of production at Ford Motor Company. Sorensen, a 60-year-old Danish immigrant, had spent his entire adult life at Ford, arriving in America as a child. He had been instrumental in Henry Ford's revolutionary creation of the moving assembly line at the Highland Park plant in 1913. This innovation transformed manufacturing. Before Ford, cars were built much like aircraft, one at a time by teams of artisans. Ford's assembly line streamlined production into sequential tasks, with workers stationed along a moving conveyor, each performing a single, repetitive job as the chassis progressed. The result was unprecedented mass production. By 1927, Ford had churned out 15 million Model T automobiles using these methods. Sorensen grasped a fundamental truth that eluded German analysts: the principles of mass production were universally applicable, even to aircraft. The Germans were correct that American aircraft companies built planes like craftsmen, but they erred in assuming that was the only way. Sorensen had witnessed the metamorphosis of automobile manufacturing from artisanal craft to industrial scale, and he believed the same transformation was possible for aircraft. The critical question was whether anyone would allow him to prove it. In January 1941, Sorensen, accompanied by Edsel Ford, Henry's son and the company president, journeyed to San Diego to visit Consolidated Aircraft. Consolidated was the designer of the B-24 Liberator bomber. During their tour of the Consolidated factory, Sorensen observed workers assembling B-24s. There were no detailed blueprints, only sketches and templates. Workers measured parts by hand, manually fitted them together, drilled custom holes, and filed edges until components matched. Each bomber was unique because every part was custom fitted. The factory could produce perhaps one B-24 per day. Consolidated's management was proud of this output, considering one bomber daily to be excellent production. Sorensen, however, found it insane. He saw what they could not: the B-24, with its 1,200,000 individual parts, could be standardized. These parts could be precision machined and assembled sequentially on a moving line. The technology already existed. Ford utilized it daily to build cars. A Ford the 5th engine, for instance, had over 200 precision machined parts that fit together with tolerances measured in thousandths of an inch. The B-24 was larger and more complex, but not fundamentally different. It was an engineering challenge, not an impossibility. That night, Sorensen remained awake in his hotel room at the Coronado, contemplating what he had witnessed. He understood how to mass-produce intricate machinery. A car engine had thousands of parts requiring precise fit. A B-24 had more, but the underlying principle was identical. Break the product into sub-assemblies. Standardize every component. Create tooling that produced identical parts. Build the sub-assemblies in parallel. Bring them together on a moving assembly line. Let the product move, not the workers. By morning, Sorensen had sketched out his entire plan on hotel stationery and the backs of placemats. He presented it to Edsel Ford at breakfast. The plan called for a factory capable of producing one B-24 bomber every single hour. Reuben Fleet, Consolidated's chief executive, looked at Sorensen's sketches and burst into laughter. It couldn't be done, he declared. Aircraft were not cars. The B-24 weighed 35 tons and had a wingspan of 110 feet. Its engines alone weighed over 1,000 pounds each. The notion of mass-producing bombers on an assembly line was, to him, absurd. Sorensen posed a simple question: if Ford agreed to build B-24s, would Consolidated provide the technical specifications and engineering support? Fleet, assuming Ford would only build sub-assemblies for final integration at Consolidated's plant, agreed. Sorensen, however, clarified, Ford would build complete aircraft or nothing. Ford would manage the entire production process using assembly line methods, or Ford was not interested. Fleet, convinced Sorensen was bluffing and certain Ford would fail, agreed to the terms. Sorensen returned to Michigan and persuaded Henry Ford to construct a factory specifically designed for mass-producing bombers. This plant would be unlike anything previously conceived. Construction of the factory, which would become known as Willow Run, commenced on April 18, 1941, at a site 35 miles west of Detroit, near Ypsilanti, Michigan. The architect was Albert Kahn, renowned for designing Ford's other massive factories, including the River Rouge complex. Sorensen provided Kahn with the specifications. The building needed to be large enough to house an entire bomber assembly line under one roof, complete with conveyor systems, machine tools, storage for thousands of parts, and space for tens of thousands of workers. Kahn designed an L-shaped structure covering 3.5 million square feet of floor space, making it, by a significant margin, the largest factory building in the world. No structure of this immense scale had ever been enclosed under a single roof. The assembly line itself would stretch 1 mile, with a 90-degree turn midway. The plant would boast its own power station, fire department, and hospital. Adjacent to the factory, Ford built Willow Run Airport, featuring 6 runways so bombers could be test-flown immediately after leaving the assembly line. The airport included 3 hangars, the largest capable of housing 20 B-24s simultaneously, along with a control tower, a cafe, and a hotel for test pilots. The total cost was $47 million, equivalent to over $800 million today. The construction itself was a monumental undertaking. 300 men, armed with saws, axes, and bulldozers, cleared 100 acres of woodland. The site had previously been Camp Willow Run, a Ford-owned property used for youth camping programs, adjacent to Willow Run Creek, which lent the facility its name. A steam-powered sawmill, brought from Henry Ford's Greenfield Village Museum, converted felled trees into 400,000 board feet of lumber for temporary construction structures. Building materials included 44,000 tons of structural steel, more than that used to construct the Empire State Building. Over 1 million square feet of glass provided natural lighting throughout the facility. The concrete foundation required enough material to pave a highway from Detroit to Chicago. The roof alone covered 78 acres. Workers installed 500 miles of electrical wiring and 93 miles of conveyor systems. The plant had its own water treatment facility and sewage system, capable of serving a city of 53,000 people. Ford invested an additional $20 million in tooling and equipment, installing 7,500 machine tools, including massive presses capable of stamping entire wing sections. Some machines weighed over 100 tons and required special foundations. The scale of the operation was unprecedented. Everything about Willow Run was meticulously designed for one purpose: mass-producing heavy bombers at a rate no one believed was possible. German intelligence learned of Willow Run in mid-1941 through various channels, including trade publications and American newspapers that openly reported on the factory's construction. Their assessment remained unchanged. The factory might be enormous, but America, they maintained, still lacked the skilled workers, precision tooling, and organizational capability to mass-produce aircraft. The German Air Ministry estimated Willow Run would produce, at best, perhaps 200 bombers per year, and likely fewer. The factory was formally dedicated on October 22, 1941, in a ceremony attended by Major Jimmy Doolittle of the United States Army Air Forces, who would later lead the famous raid on Tokyo. Production began immediately, with parts manufacturing starting that month. The first month, Willow Run produced 0 completed aircraft. In November, 0. In December, 0. In January 1942, 0. By February 1942, 9 months after construction began, Willow Run had produced exactly 0 B-24s. The plant was operational, workers were present, machinery was running, but no finished aircraft emerged. The problems were immense. American newspapers began derisively calling the factory Will It Run instead of Willow Run, a name that stuck and became a source of embarrassment for Ford. Congressional investigators visited the factory and issued critical reports, questioning whether Ford's automotive expertise could translate to aircraft production. Senator Harry S. Truman's Special Committee, tasked with investigating waste and inefficiency in the National Defense Program, toured the facility in April 1942 and raised doubts about Ford's ability to transition from automobiles to aircraft. Truman's committee was scrutinizing defense production, and Willow Run appeared to be a prime example of its failures. The plant had cost tens of millions of dollars but had yet to produce a single combat-ready bomber. The core issue was Ford's complete lack of prior aircraft manufacturing experience. While the company had produced the Ford Trimeter transport plane in the 1920s, that was small-scale production of a much simpler aircraft. The B-24 was orders of magnitude more complex. Workers were unfamiliar with aluminum, automotive workers were accustomed to steel, which was harder and more forgiving of rough handling. Aluminum required different techniques, different tools, and different training. Aircraft part tolerances were significantly tighter than automotive standards, components had to fit precisely, as any gap or misalignment affected aerodynamics and structural integrity, something cars could tolerate, but aircraft could not. The tooling designed for stamping car parts damaged the softer aluminum used in aircraft, dies that worked perfectly for steel-crushed aluminum. Sorensen had to redesign and rebuild thousands of tools, an enormous cost amounting to millions of dollars in scrapped and replaced equipment. Constant design changes from the military further disrupted production, requiring retooling that brought operations to a halt. In the first half of the first year alone, 575 engineering changes were ordered. Each change necessitated modifications to tooling, jigs, fixtures, and assembly procedures, with some changes affecting multiple sub-assemblies, creating cascading delays throughout the production system. The B-24 was vastly more complex than a car, boasting 1,200,000 parts compared to about 15,000 in an automobile. The logistics of managing so many components were staggering. Each part had to be manufactured, inspected, stored, tracked, and delivered to the assembly line at precisely the right moment. A single missing part could halt production. But Sorensen persisted. He reorganized the workflow, retrained workers, redesigned tools, and broke the B-24 into 11 major assemblies and 69 sub-assemblies. Each sub-assembly was built separately on its own production line, then delivered in sequence to the final assembly line. The center wing sub-assembly became the heart of the production system. All prefabricated structures were manufactured to precise specifications, designed to snap into place without custom fitting. A multifunction machine completed 42 precision machining operations to 2/10,000ths of an inch in just 17 minutes. This transformation from craft production to mass production necessitated retraining the entire workforce. Ford established an aircraft apprentice school at Willow Run, training up to 8,000 students per week. Classes ran continuously, teaching workers riveting, sheet metal work, electrical systems, hydraulics, and quality control. The training was intense because aircraft work demanded higher standards than automotive production. A poor weld on a car frame was unacceptable, a poor weld on an aircraft could lead to catastrophic failure in flight. Workers internalized this responsibility, knowing pilots' lives depended on their meticulous work. In September 1942, the first completed B-24 rolled out of Willow Run. It had taken 11 months from the factory's opening to produce the first aircraft. The plane was christened the Spirit of Ypsilanti, in a ceremony attended by local dignitaries and the press. However, that bomber was not sent to combat, nor were the next 55. They were used for training and transport because their quality was deemed insufficient for combat operations. Army Air Force inspectors identified defects, incomplete work, and deviations from specifications. Critics declared the project a disaster. A congressional committee reiterated that Ford had attempted to build bombers like cars, despite warnings from experienced aircraft manufacturers. While the report was accurate, Sorensen did not falter. He utilized the rejected bombers as learning tools. Every defect was meticulously analyzed, every problem became a training opportunity. Quality steadily improved with each successive aircraft. In January 1943, Willow Run produced 31 bombers that met Army Air Force standards. In February, 59. In March, 75. In April, 104. In May, 130. The production numbers continued their relentless ascent month after month. Workers mastered their jobs. Processes were refined through constant improvement. Tools became more effective as engineers identified and resolved problems. By June 1943, Willow Run was producing 190 bombers per month, more than double Consolidated's original San Diego factory output, and the rate continued to increase. The true breakthrough occurred when Ford successfully integrated all 11 major assemblies into a synchronized production system. Wings were constructed on parallel lines. Fuselages moved through their own assembly process. Engines arrived from Pratt & Whitney and were prepared in a separate area. Gun turrets came from subcontractors and were tested before installation. Every component converged at the main assembly line in perfect sequence. In April 1944, Willow Run produced 453 B-24 bombers in 468 working hours. That was more than one bomber per hour, precisely as Sorensen had promised 3 years earlier when Reuben Fleet had scoffed at his hotel room sketches. The factory operated 24 hours a day in 3 shifts, completing a new bomber every 63 minutes on average. The final assembly line moved continuously at approximately 100 feet per hour. Workers installed engines, mounted wings, fitted gun turrets, connected hydraulic systems, and installed electronics as the aircraft moved past their stations. Each worker had a specific task and a precise timeframe to complete it. The choreography was meticulously precise. At peak production, 42,000 people toiled at Willow Run. The workforce was remarkably diverse for 1944 America. Many workers had never built anything more complex than a car. 65% were women, many of whom had never held industrial jobs before the war. African American workers comprised about 10% of the workforce, despite confronting discrimination in hiring and housing. The youngest workers were 18, the oldest were in their 60s. They hailed from farms, retail jobs, and domestic service. Ford hired and trained them because the traditional pool of skilled industrial workers had been drafted into military service. Many workers commuted from Detroit on special buses, as housing near the plant was limited. The journey often took over an hour each way on frequently congested roads. Ford operated 165 private bus routes to transport workers to the plant, with public transit adding 35 more routes. Simply moving 42,000 people to and from a factory in a rural area was a logistical challenge. The federal government constructed an industrial residential community adjacent to Willow Run to house workers and their families. This community, known as Bomber City, housed 14,000 people at its peak. It featured temporary housing units, schools for workers' children, shops selling food and necessities, medical facilities staffed by doctors and nurses, and recreation areas including playgrounds and sports fields. Bomber City was essentially a small town existing solely to support aircraft production. The federal government also built the Willow Run Expressway, one of America's first limited-access highways, to improve worker transportation from Detroit. The expressway opened in September 1942, immediately easing congestion. Infrastructure that typically took decades to plan and build was completed in months due to wartime urgency. By the close of 1944, Willow Run had produced more aircraft than the entire nation of Japan built that year. Japan's total aircraft production in 1944 was approximately 28,000 planes of all types. Willow Run alone produced over 5,000 B-24s that year. And Willow Run was not the only factory revolutionizing American aircraft production. Boeing, in Seattle, was constructing B-17 flying fortresses on assembly lines using methods similar to those pioneered at Willow Run. Boeing's Plant 2 employed 35,000 workers and produced 350 B-17s per month at peak production. The factory operated with the same relentless efficiency Ford brought to bomber production. Douglas Aircraft in Long Beach was mass-producing C-47 transport planes, which became the workhorse of Allied logistics. The C-47, a military version of the DC-3 commercial airliner, was simpler than a bomber but still demanded precision manufacturing. Douglas built over 10,000 during the war. North American Aviation was constructing P-51 Mustang fighters at plants in California and Texas. The P-51 became arguably the best fighter aircraft of World War II, boasting performance that surpassed anything Germany or Japan produced. North American manufactured 15,000 Mustangs using progressive assembly methods. Consolidated's own factories in Fort Worth and San Diego were producing B-24s using modified assembly line methods they learned from Ford, with Fort Worth eventually producing about 3,000 B-24s. Lockheed was building P-38 Lightning fighters, the distinctive twin-boom fighter that served in every theater of war, producing 10,000 P-38s. Martin was building B-26 Marauders, medium bombers used extensively in Europe and the Pacific. Republic was building P-47 Thunderbolts, heavy fighters that proved highly effective in ground attack roles, manufacturing over 15,000 P-47s. Grumman was building F-6F Hellcats for the Navy, carrier-based fighters that dominated Pacific air combat, producing over 12,000 Hellcats. Vought was building F-4U Corsairs, another Navy fighter that achieved legendary performance. Every major aircraft manufacturer in America had converted to assembly line production. The transformation happened in less than 3 years. Small companies that had built dozens of aircraft per year in peacetime were suddenly producing hundreds per month. The automotive industry contributed significantly beyond Ford's Willow Run effort. General Motors produced over $10 billion worth of war materials, including aircraft engines, gun turrets, and complete aircraft. Chrysler built tanks but also manufactured fuselage sections and other aircraft components. Nash Kelvinator, known for its refrigerators, produced aircraft propellers and engines. The entire industrial base had been repurposed for war production. In 1941, American aircraft factories employed 159,000 workers and produced 19,330 aircraft. In 1942, employment soared to 2 million workers, and production hit 47,836 aircraft, more than double the previous year. In 1943, production reached 85,898 aircraft, nearly doubling again. In 1944, American factories produced 96,318 military aircraft. That was nearly double Roosevelt's original 50,000 per year target, and the aircraft kept getting better. The B-17 evolved through multiple versions, labeled A through G, each with improvements to defensive armament, engines, range, and bomb load. The final G model featured 13.50 caliber machine guns for defense, far more than early versions. The B-24 received constant upgrades to engines, defensive armament, and systems throughout its production run, with over a dozen variants produced. The P-51 Mustang that entered service in 1943 was far superior to anything flying in 1941, with a range that allowed it to escort bombers all the way to Berlin and back, a capability that completely changed the strategic bombing campaign. Early war fighters had ranges of a few hundred miles. The P-51 could fly over 1,500 miles. This meant American bombers attacking deep into Germany finally had fighter protection for the entire mission. Before the P-51, bombers fought their way to targets unescorted and suffered terrible losses. With Mustang escorts, bomber losses dropped dramatically while German fighter losses increased. American factories were not just producing aircraft, they were producing better aircraft, faster than anyone thought possible. Total production from 1940 to 1945 exceeded 300,000 military aircraft of all types. That number included trainers for pilot instruction, transports for moving cargo and personnel, fighters for air superiority and ground attack, bombers for strategic and tactical missions, and reconnaissance planes for intelligence gathering. The United States built more military aircraft during World War II than Britain, Germany, Japan, Italy, and the Soviet Union combined. Britain produced 130,000 aircraft during the war. Germany produced about 120,000. The Soviet Union produced over 150,000, an impressive achievement given that much of Soviet industry had been overrun by German invasion in 1941 and had to be rebuilt beyond the Ural Mountains. Japan produced 76,000 aircraft. Italy produced about 11,000 before switching sides in 1943. Total Axis production was approximately 207,000 aircraft. Total Allied production was over 600,000, with America contributing 300,000 of that total. The Germans noticed. In early 1943, Luftwaffe intelligence received reports about American bomber formations over Germany. The numbers seemed wrong. Too many aircraft. American bombers were appearing in formations of 300, 400, even 500 aircraft at once. Fighter pilots reported encountering endless waves of B-17 and B-24 bombers escorted by swarms of P-47 and P-51 fighters. German fighters shot down American bombers, yet more appeared the next day, and the day after. The Americans seemed to have an unlimited supply of aircraft. Luftwaffe commander Hermann Göring initially dismissed the reports as exaggeration. Fighter pilots overestimating enemy numbers during combat was normal. But the reports kept coming. By mid-1943, it was clear the Americans were deploying bomber forces on a scale Germany had never anticipated. The 8th Air Force, operating from England, was conducting daylight bombing raids with formations that sometimes exceeded 1,000 aircraft when fighters were included. The numbers were staggering. On a single mission in October 1943, the 8th Air Force dispatched 291 B-17 bombers to attack Schweinfurt ball bearing factories. Despite losing 60 bombers, the Americans returned 2 days later with another massive formation. This was industrial warfare on a scale Germany could not match. Every downed American bomber was replaced within a week. Every lost crew was replaced within a month. The replacement pipeline was so efficient that American bomber units maintained constant operational strength despite heavy losses. Albert Speer, Hitler's Minister of Armaments and War Production, reviewed German intelligence assessments of American industrial output. The numbers shocked him. American aircraft production in 1943 was over 3 times German production. American tank production was double German output. American shipbuilding was producing 1 cargo ship every day. Speer realized Germany had fundamentally misunderstood American industrial capacity. In his post-war memoir, Inside the Third Reich, Speer reflected on how German leadership had dismissed accurate intelligence about American manufacturing capability. He wrote about meetings where Hitler refused to believe reports from German observers in America. The Führer insisted American production claims were propaganda and that German quality would overcome American quantity. Speer knew by 1943 that this belief was catastrophically wrong. Germany was producing excellent weapons, but not enough of them. America was producing good weapons in overwhelming numbers. In industrial warfare, overwhelming numbers mattered more than marginal quality advantages. Speer calculated that by 1944, American industry was producing twice the total war output of all Axis powers combined. Germany, despite controlling the industrial resources of most of Europe, utilizing millions of forced laborers, and running factories 24 hours per day, still could not match American production. German fighter pilot Adolf Galland commanded Luftwaffe fighter forces from November 1941 to January 1945. He witnessed the transformation of American air power firsthand. In 1942, Galland's fighters dominated the skies over Europe. The Luftwaffe had better aircraft, better training, and more experience than American pilots. German fighters shot down American bombers at rates that should have been unsustainable for the Americans, but the Americans kept coming. By mid-1943, the situation had reversed. American fighters appeared in overwhelming numbers. Even when German pilots had tactical advantages, they were outnumbered 5 to 1, sometimes 10 to 1. Galland's pilots could shoot down American fighters, but more arrived the next day. The Americans did not seem to care about losses. They had so many aircraft they could afford attrition. One German pilot described it as trying to hold back an avalanche. You could stop individual bombers, kill individual fighters, but the mass kept coming, day after day, week after week, month after month. Galland reported to Hitler in late 1944 that German fighter forces were being overwhelmed not by superior tactics or better aircraft, but by sheer numbers. The Americans were producing more planes than Germany could destroy. Galland requested permission to withdraw fighters from the Eastern Front to defend German cities. Hitler refused. He still believed Germany could win through superior technology and fighting spirit. Galland knew better. The war had become a contest of industrial production, and Germany was losing badly. At age 30, in 1942, Galland had become the youngest general in the German armed forces. By 1945, he was flying missions with an experimental jet fighter unit because conventional piston-engine fighters could not compete with the mass of American aircraft flooding European skies. In December 1944, Germany launched the Ardennes offensive, known as the Battle of the Bulge. The attack achieved initial surprise and made significant gains. Within 3 days, American air power appeared in overwhelming force. The weather had been overcast for the first days of the offensive, grounding Allied aircraft. German planners had chosen this timing specifically because they knew clear weather would bring American air superiority. On December 23, the weather cleared. What happened next demonstrated the full power of American aircraft production. Hundreds of P-47 Thunderbolts and P-38 Lightning fighters attacked German columns. Formations of B-26 Marauder medium bombers struck German supply lines. Heavy bombers from the 8th Air Force diverted from strategic targets to hit German communications centers and rail yards. From December 23 to January 16, Allied air forces flew over 74,000 sorties and dropped 111,000 tons of bombs. They destroyed 11,378 German transport vehicles, 1,161 tanks and armored vehicles, 507 locomotives, 6,266 railroad cars, and 472 gun positions. German troops in the Ardennes had never witnessed such concentrated air power. The sky was filled with American planes. One German officer later described it as a vision of industrial hell. Everywhere you looked, American planes. They controlled the sky completely. German anti-aircraft guns shot down some aircraft, but more appeared immediately. The Germans had no effective counter. An Air Command and Staff College research paper later concluded that the Battle of the Bulge was the first time air power was used to halt a counteroffensive. The German advance rate of 20 km per hour per day continued until December 23, slowed on December 24, and ceased on December 25. The timing perfectly aligned with the air effort. The Ardennes offensive failed largely because American air power destroyed German supply columns and trapped German forces in a killing zone. And that air power existed because of factories like Willow Run. By January 1945, the Luftwaffe had ceased to exist as an effective fighting force. Germany still possessed fighters and pilots, but fuel shortages, pilot attrition, and an overwhelming numerical disadvantage meant German aircraft rarely challenged American air superiority. American bomber formations flew over Germany in daylight with minimal losses. Fighter escorts ranged across German skies hunting for targets. German factories, rail lines, oil refineries, and transportation networks were systematically destroyed from the air. The strategic bombing campaign that devastated Germany was made possible by American aircraft production. Without the factories at Willow Run, Seattle, Long Beach, and dozens of other locations, the bombing campaign could not have been sustained. Each B-17 or B-24 that was shot down was replaced within days. Pilot losses were replaced by new crews trained in American flight schools. The Germans could not replace their losses at the same rate. When American industry finally ceased wartime aircraft production in August 1945, the total count stood at 300,000 military aircraft. That included 37,000 B-24s from multiple factories. Willow Run alone had built 8,685 of them, including 1,890 B-24 knockdown kits shipped to other plants for assembly. The final B-24 left Willow Run on June 28, 1945. Charles Sorensen, however, was no longer at Ford. He had been forced out in a power struggle with Henry Ford on March 13, 1944, just as Willow Run reached peak production. Sorensen went to work for Willis Overland and never returned to Ford. He received no official recognition for Willow Run during the war, no medal, no commendation, no public acknowledgement. The success of Willow Run was attributed to American industrial strength and Ford Motor Company, but Sorensen's name rarely appeared in official accounts. William Knudsen, who had grappled with Roosevelt's seemingly impossible target in his Detroit office in May 1940, became Commissioner of Industrial Production on the National Defense Advisory Commission on May 28, 1940. He spent the next years coordinating industrial mobilization across the entire American economy. In January 1942, Knudsen was commissioned as a lieutenant general in the United States Army, the only person in American history to enter the military directly at a 3-star rank without any prior service. He worked with the War Department until 1945, organizing the production of tanks, trucks, weapons, ammunition, and aircraft. After the war, he returned to private industry. Knudsen later asserted that American victory in World War II was decided in factories, not on battlefields. The side that could produce more weapons, more ammunition, more aircraft, and more tanks would win. Everything else, he believed, was tactics. Knudsen was convinced American industry had not merely defeated the Axis powers, it had buried them under an avalanche of production they could never match. His assessment was correct. The phrase, "arsenal of democracy," coined by President Roosevelt in a December 1940 radio address, was not propaganda, it was literal truth. American factories produced 64% of all Allied military equipment used in World War II. By 1944, the United States was producing more war material than all other nations in the world combined, including its own allies. Adolf Hitler lived to witness the consequences of his profound miscalculation. By April 1945, Soviet armies were fighting in the streets of Berlin. American and British forces controlled Western Germany. German cities lay in ruins from strategic bombing. The Third Reich was collapsing. In his final days in the Führerbunker, Hitler blamed his generals, blamed traitors, blamed everyone except himself and his advisors, who had dismissed American industrial capacity as propaganda in 1940. Those advisors had told Hitler that Roosevelt's 50,000 aircraft per year was impossible. They had assured him American industry could never mobilize for total war. They had convinced him Germany would win before America could build enough weapons to matter. They were wrong about everything. The 50,000 aircraft per year that seemed impossible in May 1940 had been exceeded by 1944. American factories built 96,000 aircraft that year alone. The total over 5 years reached 300,000. Germans had called it propaganda, America built the planes anyway, and those planes destroyed the Third Reich from the air. Albert Speer survived the war and spent 20 years in Spandau prison as a convicted war criminal. In his memoir, written in prison, Speer reflected on Germany's strategic mistakes. He wrote that the greatest error was underestimating American industrial power. German leaders had looked at America's small peacetime military and concluded America was weak. They had ignored America's massive industrial infrastructure, its engineering capability, its tradition of mass production innovation, and its capacity for rapid mobilization. Speer calculated that by 1944, a single American factory like Willow Run was producing more aircraft per month than entire German industrial regions. He wrote that Hitler's decision to declare war on America in December 1941 was the moment Germany lost World War II. Not because of American military power at that moment, America barely had an army, but because declaring war on America guaranteed that American industrial capacity would be turned fully toward destroying Germany. And once that industrial power was mobilized, Germany had no counter. Speer stated that if German intelligence had accurately assessed American industrial potential in 1940, Hitler might have made different strategic choices. But German analysts looked at American aircraft production in 1939, saw fewer than 3,000 planes, and assumed that represented America's maximum capability. They failed to understand that American industry had not yet even tried to build aircraft at scale. Production in peacetime was constrained by limited military budgets and small orders, not by industrial capability. Once American industry applied mass production techniques developed for automobiles, shipbuilding, and machinery to aircraft manufacturing, the production numbers increased 32-fold in 4 years. No German planner had thought that was possible. The staggering achievement of American industry during World War II stands at 300,000 military aircraft from 1940 to 1945. That number is difficult to comprehend due to its sheer scale. 300,000 aircraft. If you laid them wingtip to wingtip, they would stretch from New York to Los Angeles and back twice. If you stacked them one on top of another, the stack would reach beyond the edge of space. The combined weight of all aircraft produced was over 6 billion pounds of aluminum, steel, rubber, and electronics. The production required 150 million board feet of lumber for crating and shipping. It consumed 2 billion rivets. It required enough electrical wiring to circle the Earth 40 times. Manufacturing employed over 2 million workers at peak production in 1943. Those workers operated in factories totaling over 100 million square feet of floor space. The factories used more electricity than the entire city of Detroit. They consumed raw materials shipped from every state and multiple countries. American industry built the supply chains, trained the workers, designed the tools, and solved the production problems in less than 4 years. From Roosevelt's speech in May 1940 to peak production in 1944 was exactly 4 years. In that time, American aircraft production increased from fewer than 3,000 planes per year to 96,380 planes in 1944 alone, a 32-fold increase. No other industrial mobilization in history matched that scale or speed. When historians analyze how the Allies won World War II, they often focus on battles: D-Day, Midway, Stalingrad, the Battle of Britain. But those battles were won with equipment built in factories. The B-24 bombers that struck German industry were built at Willow Run. The P-51 fighters that escorted those bombers were built at North American aviation plants in California and Texas. The C-47 transport planes that dropped paratroopers at Normandy were built by Douglas in Long Beach. The Liberty ships that carried supplies across the Atlantic were built in shipyards using assembly line methods adapted from aircraft production. Every weapon, every vehicle, every bullet came from American factories. The soldiers, sailors, and airmen who used those weapons were brave. The generals who planned operations were skilled. But without the industrial base providing equipment in overwhelming quantities, tactics and courage would not have been enough. Germany had brave soldiers and skilled generals. Japan had highly trained pilots and experienced commanders. Both lost because they could not match Allied industrial production. American industry made Allied victory inevitable. Once the factories were running at full capacity, the Axis powers were fighting a war they could not win. The outcome became a matter of time. The story of how America built 300,000 aircraft in 4 years is not just a military history, it is an industrial, engineering, organizational, and political story. It is a story about Charles Sorensen staying up all night in a San Diego hotel room, sketching an assembly line for bombers on placemats because he knew mass production could work. It is about 42,000 workers at Willow Run, most of them women, most with no prior manufacturing experience, building 1 bomber per hour through 3 shifts every day. It is about Albert Kahn designing a factory larger than anything previously built to house a mile-long assembly line. It is about William Knudsen coordinating industrial mobilization across thousands of factories in 48 states. It is about Roosevelt setting targets that seemed impossible, and American industry meeting them. It is about German intelligence analysts looking at American production numbers in 1939 and concluding Roosevelt's speech was propaganda. Those analysts made a fatal error. They assumed American peacetime production represented maximum capacity. They did not understand that American industry had not yet tried to build aircraft at full scale. They did not anticipate assembly line mass production methods would work for aircraft. They could not imagine factories like Willow Run. And by the time German leaders realized their mistake, it was too late. The American industrial machine was fully mobilized and producing weapons faster than Germany could destroy them. That was the real lesson of World War II. Industrial capacity matters more than tactics. Production wins wars. An American industry outproduced the entire world combined, delivering 300,000 aircraft in just 4 years, from fewer than 3,000 per year in 1939 to over 96,000 in 1944. The Germans called it propaganda. America built them anyway. The men who fought against America left the most honest record of its power. Battlescars brings you one of those stories every single day. If this one held you to the end, subscribe, tomorrow's story is already waiting. And your next one is right here.